students. I am Dr. Rohini Shivananda, Faculty, Department of Psychology, Bangalore University. Today, we will be discussing Unit 1 of Module 18. The Module 18 tells about inferential statistics, Pearson and Spearman correlation coefficient tests, and regression. Now first, let us discuss about objective of this unit. Empirical research is of different types. Some methods aim to describe the patterns in observed phenomena. Some attempt to find the cause of phenomena. Others attempt to study the degree to which two or more phenomena are associated or vary in respect to one another. Earlier units have explained the different statistical techniques to describe the patterns found in data. They are mainly measures of central tendency such as mean, median and mode, or measures of variability such as range, standard deviation, etc. The former describe the commonness found in the data points, while the latter indicate the extent to which data are spread around the central tendency measure. These are called descriptive statistics. Other types of statistics provide numerical values about the sample, which help to make inferences or draw conclusions about the larger population from which the sample is drawn. Primary objective of this module is to explain some of the inferential statistics such as correlation and regression. For example, to analyze the attitude of students towards a newly launched product, it would be practically impossible to study every student who is exposed to that product. In such a case, statistical measures from a representative sample of say about 200 students, their attitude are used to generalize how the entire population of students in that place and time view the said product. These statistics are called inferential statistics. Now let us come to correlation. One important type of research is correlation research, which aims to study how two variables are related. In empirical research, a variable refers to any phenomenon that can vary or have different values and can be measured. For example, height of persons. People can be different measures of tall or short. The inferential statistic used here is called a correlation, which is used to measure and describe the degree of association or relationship between two variables. In a correlation, the two variables are simply observed as they exist naturally in the environment. No attempt is made to control or manipulate the variables. For example, one may find that a cloudy day is associated with increase in temperature. There is no way of actively changing the variables in question, but data may be collected over several days or months to check if there is a possible link between the two. Now let us describe about correlation. A correlation requires two sets of scores, in which one set implies two scores for each individual, one score from each of the two variables. These scores are normally identified as X and Y. For example, the number of hours of screen time of a student, that is, time spent on electronic gadgets, may be designated as X, and the academic performance, that is, marks obtained in the examination, may be designated as Y. Every member of the sample obtains these two scores. Each pair of scores can be listed in a table or presented graphically in a scatter plot or scattergram. For each individual, the score on X and the corresponding score on Y is plotted as a data point. In this manner, each individual is identified by a single point on the graph. Similarly, the points for all individuals being studied are plotted. Plotting of all the available scores results in a mass of data points on the graph. The scatter plot allows one to view any patterns or trends existing in the data and provides an approximate idea about the extent and type of relationship between the two variables. Different patterns are possible, such as in the figure 1, you can see a person with low screen time has low marks and a person with high screen time has a high marks. This figure indicates the scatter of the data points to be rather uniformly moving from lower left corner to the upper right corner, implying positive correlation or direct relationship. In figure 2, you can observe a person with low screen time has a high marks and a person with high screen time has a low marks. There is a clear trend of data points scattered from top left corner to the bottom right corner, implying a negative correlation or inverse relationship. In figure 3, a person with low screen time may have low marks and another person with low screen time may have high marks. Similarly, a person with high screen time may have low marks and another person with high screen time may have high marks. Screen time data shows no identifiable pattern with academic performance data, implying no correlation. While viewing a scattergram, attentions need to be paid to outliers. An outlier is an individual with an X or Y values that are substantially different from the values obtained for the other individuals in the data set. The data point of a single outlier can have a dramatic influence on the obtained correlation value. For example, if all but one student has an extremely high score on screen time, it will have an unnecessarily strong influence on the correlation value and distort the understanding we obtain about the remaining sample. Now, we can discuss about correlation coefficient. A correlation is notified by the letter R. The R value is a value calculated from a formula which can range from -1 through 0 to +1. The correlation may be negative or positive as identified by the minus or plus sign. In a negative or inverse relationship, the two variables tend to move in opposite directions. As the value of X increases the one individual to another, the value of Y decreases and vice versa. In a positive or direct relationship, the two variables tend to move in the same direction. As the value of X increases from one individual to another, the value of Y also increases. As the value of X decreases, the value of Y also decreases. For example, screen time, that is denoted by X, and academic performance denoted by Y. As the screen time of a student increases, academic performance decreases. Similarly, In the other example, the increase in the advertisement slots of beauty products with popular movie actress denoted by X increases the sales of the products that is denoted by Y. At another example, the telecast of popular reality show denoted as X in any time of the day will not have any change in the number of viewers, which is denoted by Y. The degree or strength of the relationship is identified by the numerical value of the correlation. A perfect correlation is identified by 1.0, which means that with change in one variable, there is an exact proportionate change in the other variable. On the other hand, a correlation of 0 indicates that change in one variable is associated with no corresponding change in the other variable. Intermediate values represent varying degrees of the relationship. The thumb rule of interpreting the correlation coefficient is that the closer the value is to 0, the weaker the association. The closer the value is to 1, the stronger the association. Using the figures given above, figure 1 probably indicates a correlation of 0.90. Figure 2 indicates a correlation of minus 0.80 and figure 3 a correlation of 0.10. Correlation coefficients may be calculated using the various types of formulae depending on the data to be analyzed. Data can be of various types such as scores, for example, marks obtained in the exam. Ranks, for example, preference for different channels in the television. Frequencies are the number of times a value occurs. For example, number of times an advertisement shown in a popular television program, etc. There are different formulae for data in which the values of X and Y are both continuous scores, or both in the form of frequencies, or where one of them are scores and the other are frequencies, etc. For most practical purposes, data that are in the form of scores are commonly analyzed using the Pearson product moment correlation. Thank you.